A new quadrilateral that we're going to learn about in this section is called a kite. Kite is a quadrilateral with two distinct pairs of congruent, and then they must be congruent and adjacent sides. So in general this might look like this. So let's have two sides. Now these two sides are adjacent, and we'll say that they are congruent. Okay, so they have the same length. And then we have two more sides of the quadrilateral. Let's say something like this. And so these two sides are adjacent, and we'll say that these are also congruent. Now the term distinct here is important. What that means is that this pair, though they're congruent to each other, they're not congruent to this pair. So they're two distinct lengths. If they were the same length, then we would have a different figure, which we'll learn in a few minutes. So distinct is kind of important here. So one theorem about a kite. In a kite, one pair of opposite angles are congruent, or one pair is congruent. So let's look at this kite. Now we're talking about opposite angles, so we've only got two pairs of opposite angles to consider. First of all, let's call this 1, 2, 3, and 4. 1 and 3 are opposite angles. Do those just intuitively or upon inspection, do they look congruent? No, they don't. You can actually sort of tell 1 is an acute angle and 3 is an obtuse angle. So that must mean that perhaps 2 and 4 is congruent. And it turns out that it is. Here's a small proof of that. So given kite, we don't have a symbol for kite, so we just write out kite. Let's call it A, B, C, D. We'll say this is A, B, C, D. So given the kite A, B, C, D, we want to prove that angle B, in this case, is congruent to angle D. It's real easy to do. We can draw a diagonal. Draw diagonal AC. This is a determined condition. Because there is only one line through any 2 points. Determined condition. One line through any 2 points. Now we can see that AB is congruent, line segment AB is congruent to line segment AD. Also, we know this was given. We also can see that BC is congruent to DC, but also this was also given. We also use when we draw this diagonal AC, we can use our identity property. AC is congruent to AC. And now we have side, 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 so triangle ABC is congruent to triangle ADC. ABC is congruent to ADC, and that's side, side, side. And then using CPCTC, we can say that angle B is congruent to angle D. And our favorite part, put that problem in its grade.